Okay, today I will introduce what is TinyML and Hello World project of TinyML. TinyML mean tiny machine learning. Mm, this is the today our table of content. First, okay, we can go through one and one step by step. Uh, First, what is tiny machine learning? Or what is TinyML? Uh, right. TinyML is the set of technologies in ML and embedded system to make user smart application on extremely low power devices, not our classical powerful GPU or CPU. How to implement ML algorithm on small low power devices. That uh, that's all of the TinyML. We discussing TinyML. Right? Okay, then why we want to run ML algorithm on microcontrollers? These are the reasons. Microcontrollers is the inexpensive device and easy to program, and microcontroller power also enough to implement some deep learning, machine learning algorithms. uh, you can think you can deploy a simple linear regression model on microcontroller easily, and also we can implement neural network also on the microcontrollers because we don't need a cloud solution, and microcontrollers are already low price devices. Okay. Why run ML on locally? Main two reasons we have run ML on locally. First one is reducing latency and reduce power consumption. Okay, how to reduce latency? I think we have ML model on cloud platform. Then we have to get requests on the cloud platform and process it and get response after the get response from a cloud platform. That journey can generate some latency, but we implement our ML algorithm or neural network or deep learning algorithm on locally on the microcontroller. We can reduce our latency and reduce power consumption because you can see um, three main parts of microcontroller power consumption: um, CPU and sensoring part, and communication part. You can see communication part also consume power rather than CPU and sensor part, because that's why we want to run machine learning on locally. Mm, this is tiny machine learning pipeline, how we can implement tiny machine learning system step by step. We have to collect data and prepare our data, and this is all about the model training. After the build model, we have to convert our model compatible code with embedded device. We don't try build model on microcontroller. We try only deployment of model. Deploy on microcontroller. Okay. This is a simple introduction to neural network. I think you guys also already know about what is neural network like thing. Um these are the some frameworks we can use implement our neural networks. Mm, right. This is a Hello World project of Time Machine Learning. This is a funny thing because you already know every programming language we have a Hello World project. It's called Pink Hello World. That's related to programming part. And every microcontroller or microprocessor, we first our first project is a LED beam. That's a Hello World project of microcontroller or microprocessor. And get tiny machine learning. Tiny machine learning Hello World project of generate a sine wave using machine learning model without using mathematical function, because we use mathematical function for compute sine function on microcontroller. It's heavy task for microcontroller, but we try to implement sine wave model in the machine learning and deploy that model on microcontroller. We can use TensorFlow Lite for do that task. Okay. So not use TensorFlow, use TensorFlow Lite, light version of TensorFlow. Right. Um, I get all the details from that book, TinyML, and that book, chapter 4, contain a hello world of tiny machine learning, build and train model. I will show you all things, coding part and all things. Okay. This is the TinyML hello world project model training part, first part. Uh, I already run all the things. Okay. First, we have to uh, get our libraries and all the things and create data set. That data set was a sine function, but real world scenario, we can't generate like thin sine function. That reason we have to realistic this sine function, adding some noise data. After data pre-processing part, we have to split our data training and testing part. Uh, you can see training data, blue color, testing data, validation data, all the things. And okay, then we have to build our model and train it. Um, in that part, training the model. Okay, you can see our model loss value start from that value and reducing the value to okay, that value. After training, we can plot our training and validation loss functions as well. Uh, okay, this is a okay. Then after we can see, we can check how to perform our model. I think you guys can see there's the actual model and our predicted model. There's almost work as a sine function, because then we can implement we already implemented our sine function machine learning model without using mathematical model. Okay. Final thing, very critical thing, we have to export our weights and biases on neural network uh, using a C++ code, because we try to implement that model on Arduino. Then we have to get model weights and biases as a C++ fault, right? After get these weights and biases, we can copy that all the things on this file. Uh, this Arduino file contain our model building part, model deployment part, um, and these are our trained model weights and biases. These things. Mm, Then after we can program that code Arduino, not no need Arduino Nano 33BL or Arduino Uno also perform this code. I will show you small demo. Mm, yeah. Now you can see a sine function perform on Arduino, not is a neural network running on the Arduino. And another thing, edging pass. Edging pass also very nice platform for train our edge embedded like embedded machine learning models like edge AI things we can do using edging pass. Uh, I think our kids also can play with the gym balls because after completing all the things, they can move on with the gym balls like advanced platforms. Because gym balls work with our mobile phone also work with the gym balls. I will show small demo how do gym balls work with our mobile phone. Okay, that video I published that day. Yeah. Then you can see my mobile phone, Wi-Fi, Bluetooth, data, all the things turned off, and it contain in a classification model. I do something, right? Then you can see it classify as a snake. Yeah. Then it's classified as a up down gesture. Mm. Then, okay. Then likewise we can implement our ML models using a Impulse also. Right. Uh, this is all about my today's session. And I have a small YouTube channel. It contains some uh, sessions, how all the things about registers and how to implement machines using flip-flop like things, small things, and okay, these are the Arduino Nano 33 PLC sense. Uh, it contain nine different sensors. It contain I think nine sensors it contain and can do some image classification task also. Mm, yeah, that's all about my side. I hope share all the things with you. I share that book also, and I will share all the codes. You can simply run it and get some hands-on experience. I think today is a small session about tiny machine learning. Okay. You guys have any question?